All right, so vertex form, here we go. Subtract 319. I have a question about 319. Um, in Monsters Inc., when George gets the sock, is it a 2319? Important question. What's his name? George Sanderson? Mrs. Talbot, you're skipping steps. Don't do it. Okay. Woo, here we go. All right, so first step, move a constant. Second step, GCF. What do I need to GCF here? 4. Great job. And what is 72 divided by 4? 18? Yeah. Man, I think you guys are more awakesies than me. Okay, x squared, negative 18, a break into negative 9 and negative 9. What's wrong? What? $81. Okay, so I add 81 into here, but it's really not 81. What is it? 324. Yeah, it's really 324 because 4 times 81 is 324, which will show you that now your number is reasonable. Factor and move the constant. How are those coming? Solid. Wish you had that multiple choice question to do over now. I don't know, Mrs. Tom, because I'm not sure what I got wrong. Okay, let's go down to number 6. Um, we're gonna number 6 is weird. We are gonna cheat a little bit, so there's going to be some cheating. Which is really not cheating. It's utilizing your tools, but kind of cheating. So switching down to number 6, we're going to do all the stuff and things. We're going to cheat with the graphing calculator a little bit. But it's good review for a square root. So you have original f of negative x and negative 1 times f of x. Okay, and this is going to be weird. It's going to be weirder than usual. And the reason is because if you put negative x in here, there's going to be variability with what your answer could be. Okay, so let's just start with the original. That's easy. X plus 4. Great. No issue there. I can write the problem down again most of the time correctly. Okay, now negative x. This would be square root of negative x plus 4. And on all of these problems, I have asked you to analyze whether or not that would come out to a negative or positive. And the question really is, depends. It depends on what x is. If x is bigger than 4, then you're going to have an I, which would not work. If x is smaller than 4, you could do it. So this really is all you can do because you don't know what your answer would be. So that's it, which just means that these two things do not match. Okay, and then wait till we get the graph and it'll make sense. Okay, so now -1 times the original is just going to put a negative outside. Okay, and none of them match, and it's neither. It's not really just neither, it's neither. Okay, and now we're going to say why it makes sense that it's neither, graphically speaking. So if you guys could get your calculator going for the cheating, get ready to cheat. Here we go. So hit the y equals button. I've got stuff in there from yesterday, so I'm going to clear it out by hitting the clear button. And I want to make sure that there's nothing in my y equals and none of the plots are on. And what you do is go math. Nope, I lied. Don't do that. That's harder. Go second x squared. Second x squared. You see the little square root? It's like living above it, above the button. But I don't really want it there, do I? Second x squared. And then x plus 4 inside. And I'm a nerd, so I will arrow out just to, finish it off. Okay, now everyone in the class hit the zoom button, which is the top middle one, and then the number 6. And that'll give us all the same picture. So my endpoint is -4, 0, which you could have gotten from the equation. Do you guys see the endpoint, -4, 0? Okay, and now I'm going to cheat and go second graph and write down a couple other coordinates for me to graph. Second graph. Your plot one is on. See how it's highlighted? Mm-hmm. So you have to scroll up to it with the arrow keys and then hit enter. It will turn it off. And then
Mine have the parentheses there. And like the square root isn't going over access.
Oh, that's because your calculator is older, so you're going to have to put the end parenthesis after what you want under the square root. And then if you want anything outside the square root, that'll have to be outside the parenthesis. Okay. Okay, now this thing. If I fold my paper on the y-axis, will it match up? No. And if I turn my paper upside down, will it be the same graph that I had before? No. Okay, there's no symmetry here. So really, I could have concluded that it was neither, just from the fact that it's a square root graph. They don't really have symmetry. Okay. I think we are done with the packet, so you can scooch that to the side. I would like to stamp later the homework that you definitely did last night and aren't doing right now. Okay, you're going to need a graphing calculator for this whole deal, so. Okay, everybody, so number 1A, what is this? What shape is this? It's a parabola. What is its locator point? -3, -5. And this is the next question I have for you. How many solutions are there to this parabola? How many solutions are there? More? Okay, let me ask you a different way. How many points are on this parabola? Infinite. This parabola has infinite solutions. And the solutions are points on the parabola. Okay, so in B, I've now taken that same parabola and I've equaled it to a line. How many solutions are there to this equation? Two. Why are there two? I only said it 500 times yesterday. Hmm. Plus or minus, yes. Whenever you square root both sides, you need to have a plus or minus. So this is a parabola because it equals y, has infinite points on it. It means it has infinite solutions. Now that we've equaled it to a number, it has two solutions because when you square root both sides, there's a plus or minus. Okay, so first thing we're going to do is solve it. So if I were to solve this, and I'm going to rewrite it down here. Using the techniques that we were practicing yesterday on whiteboards, what would be the first thing I would do? Add 5. Add 5. Why would you undo the beautiful complete of the square that somebody did for you? Mm-hmm. Now what? Square root both sides. Because x plus 3 squared is a perfect square, so you can do that. And now you have x plus 3 on the left side and plus or minus 3 on the right side. Okay, so now two equations. Okay, any questions about that so far? All good? All making sense? Okay, now what I want to do is to talk about solving by graphing. And I know they had this in the homework last night because we wanted to see what you remember. But what I want you to do is take the left side of this and put y1 equals and y2 equals the other side. I want you to imagine that somebody, maybe it was the same person who completed the square for you, did equal values method, and because we both equal to y, equal them to each other. Let me say that again. Somebody, before you got here, said, oh, both of these equal y, so I can equal them to each other. It's called equal values method. We haven't done it in quite some time. It's been a hot minute. But if both things equal y, it makes sense that they equal each other. Okay, so my thought process is if I can graph this and graph this, they should have points of intersection, which should be at 0 and -6. Ah, okay. All right, so let's graph the parabola first. As we said, what's the locator point? Okay. Okay, and I told you guys to make a table and go down to and up to. And I told you guys to do mental math, but we're not going to do mental math today. You're going to cheat and use the table. So you just need these values for now. So type x plus 3 squared minus 5 into y1. Well, I'm going to do second graph because I want to see the table. I want to copy these numbers down off of my screen. So if I go to second graph, and then I can scroll on the table to get the ones that I want. So -3, -5 makes sense. And you can use symmetry to kind of narrow down how much work you do. Okay, now I'm going to teach you a trick. It's a trick for the quiz. A trick you can use your whole life. It will make everything simpler for you if you have an a value of 1. Do you see that this parabola has an a value of 1? Everybody see that this parabola has an a value of 1? Okay, you can graph every parabola that has an a value of 1 by going over 1, up 1, over 2, up 4, over 3, up 9, over 4 up 16 because you're just going to square the number. So you can cheat if you have an a value of 1 without doing the table. You can actually just go over 1 up 1, over 2 up 4, over 3 up 9. Anyway, okay, so now draw your parabola in. Okay, and what does the line y equals 4 look like? All lines are straight. I'm looking for more specificity. Horizontal is what I'm looking for. So there's y equals 4. Horizontal line at 4. Okay, so now let the magic happen. Where did those two things cross? 0, 4 and -6, 4. And what were the x's? And where did we see those prior? Okay, so I just unleashed to you a huge way to cheat on everything. You could take every equation that's given to you forever for the rest of your life, like unless it's not a function. Put the left side in y1, the right side in y2 in the calculator, and see where they cross and solve for x. You can use it to check anything. You can use it to check. I mean, we have no work equals no credit on there for a purpose, but you can always check your answers if it's just a solving problem. Now, Miss Rice and I, we're smart. We're smart ladies. We try not to just put straight up solving questions on your tests. We try to ask stuff and things and other stuff and use this to find this and describe and blah, blah, blah. So, just keep that in mind. Okay, that's number 1. So we have now unleashed the power of solve by graphing, which is great. Are you with me so far? Okay, now we're going to practice it on number 2. So we're going to do the same thing. I'm just setting my parabola equal to different stuff. And we're going to skip graphing it. We're going to go to the graphing calculator to help us. Ready? Okay, what do I do first? Add 5. Great job. What? No, it's fine. Just wait till we get to B. We're good so far. Okay, then what? Square root. I really like your apprehension though. Okay, so what would the left side be? X plus 3. What would the right side be? Plus or minus 4. Okay, so I got my answers. I got 1 and -7. And what I want to do now is show you how you can get 1 and -7 from the graph. Okay, so I took the left side and equaled it to y1. I took the right side and equaled it to y2. I'm going to go in the calculator. So the left side is already in there if you've been doing the stuff along with us. And then I'm going to put the right side in y2. With me so far? Yeah. Okay. Hit the graph button. Crap. 11's up too high. We can zoom. Zooming is kind of hard. What I want you guys to do is hit the window button. Hard to see. I mean, the intersection points if you zoom out. Yeah, so we're going to take the Y max and just make it 15 instead of 10. So take your Y max, make it 15 instead of 10, then hit graph again. Ah, haha. Okay, so what we're going to do is say, okay, the two things are supposed to cross at x equals 1, x equals -7. Does this look like x equals 1 right here? Yeah. Okay, let me count 1, 2, 3, 4, 5, 6, 7. Does that look like -7 right there? Yeah. Solved. You see how dangerous this is? Yeah. Okay, now number B, that makes sense. Letter B is not going to be as pretty. I'm sorry to tell you. Okay, so you have to have a non-pretty one, and that's okay. You'll still be able to do everything you need to do. Four and two, 2 and 2. Yep, yep. Okay, I've been trying to drill it into everybody about what to do with the number. What do you do? Put it in the front so that it looks like a quad formula answer. Okay, now what I want you to do is say, okay, I'm gonna verify this on my graph with Mrs. Talbot. This is my test. She wants to see all my work. I want to check my work on the graph. Okay, this would be my final answer for my solutions. Does that make sense? Does that make sense? Okay. What I want you to do is go in your calculator and find decimal approximations for your two solutions. Okay, so I'm gonna go, all right. By the way, to get out of the graph, you can go second mode. There's like a quit right above it. It'll get you back to the original screen. So -3 plus 2 square root 2. Yep, negative 0.17. Okay, now go back to your y equals, and instead of 11, put 3 here. So change your 11 to a 3. Hit the graph button. We actually can put it back to zoom 6 if we want, but it doesn't matter. Just remember, zoom 6 will get you back to the original window. Okay, now what you can do is hit the trace button. The trace button is right next to the zoom. And you can use it. It's not perfect, but you can use it to kind of help you see if your intersection points are correct. So I have negative 0.17. Hold on. This says it's really close to negative 0.15. This is not perfectly on that point, so we know we're good, right? Do you see what I mean? Like it's really close. Okay, and then trace along la di da di da di da di da di da di da la di da di. Okay, and then this one says somewhere between negative 5.9 and negative 5.75. So that means that that one's correct. So if they come out weird, you can still do it. You just get the decimal approximations and use trace to kind of make sure you're in the ballpark. It's not going to be perfect. But you just want to be in the ballpark. Okay. Flip your notebook over if you're doing stuff that's the same size as me. We're going to review a couple of things from yesterday real quick. Fraction busting techniques. Okay. Number 3, fraction buster. What is the least common denominator? 20. You need to make sure you think about what these numbers on the denominator go into, not what goes into that. Okay, so I'm going to do 20 times 20 times 20 times. Okay, so I just multiplied all of the tops by 20. Notice that I put the binomial in parentheses because I have to multiply the whole thing by 20. Okay, now here's the magic moment. If I picked the right number, when I divide, all of them should come out to be whole numbers now. So 20 divided by 4 is 5. 40 divided by 5 is 8. 180 divided by 10 is 18. I said the answer, not the problem. And voila. Okay, now I want you guys to try something really, really cool. Put the left side in y1 and the right side in y2. Just make sure to put the x minus 5 in parentheses. So x minus 5 divided by 4 plus 2 divided by 5, 9 divided by 10. Okay, hit the graph button. Do they cross at 7? Nice. You see the power of the solve by graphing. It's awesome. Okay, last problem of the day. This is a fraction buster. You might not know it, but it is. It's a decimal buster. Nobody wants to diamond and box decimals, and I'm certainly not going to do quad formula for this. What can I multiply by to make it look pretty? 2. What multiplies to be -6 and adds to be +5? 6 and -1. Yes. Everyone always forgets about the times one. Okay. Now, this is where I'm hopefully gonna make you do like the head smack thing, the head smack emoji. What would happen if I put the left side of the equation into y1 and the right side of the equation into y2? What? Equal to 0, right? What would I be finding? X-intercept. You guys have been doing solve by graphing the whole time. You just didn't know it. Because when it equals 0, you're finding the x-intercept, so you're finding where it crosses here. You just didn't know. You didn't know it was solved by graphing, but you could now put in 0 and then see where it crosses. Or you could just graph the line and see where the x-intercepts, or the parabola, see where the x-intercepts are. So you've been doing this all along. You just didn't even know that it worked for everything, not just x-intercepts. It works for any intercepts. This one was 9/10 intercepts. Okay, that's it for that. Can you open your notebook to this and last night's homework? So just so I can see 10 through 13 and today's.